Look up tonight, and you'll think you're seeing the sky as it is. The stars, right there, present tense, shining now. That's the one thing the sky will never show you. Not a single point of light up there is happening now. Every star you can see is a photograph, some of them thousands of years old, a few of them pictures of things that no longer exist. The night sky is not a view, it's a memory. And once you understand how it works, you'll realize something stranger. You have never, not once in your entire life, seen the present moment. Not the stars, not this screen, not the face of a single person you love. We treat sight as instant. You open your eyes and the world is simply there, delivered the moment it happens. Light feels like nothing. No travel, no delay, no cost. For almost all of human history, everyone assumed exactly that we see things as they are, the instant they are. It's wrong at every scale. Even in this room, the light bouncing off your own hand reaches your eyes a few billionths of a second after it leaves. Tiny, but not zero. Nothing you see is ever the present. It's always by some margin the past. It took one quiet measurement in 1676 to prove it. At the Royal Observatory in Paris, a Danish astronomer named Ole Rømer was tracking the moons of Jupiter. One of them, Io, slipped behind the planet like clockwork, except the clock kept drifting. When Earth was near Jupiter, the eclipses came early. When Earth was far, they came late. Rømer saw what nobody had dared to claim. The difference was travel time. Light wasn't instant. It had a speed. When Earth sat farther away, the light simply had farther to go, and it arrived minutes behind schedule. He worked out that light needed about 22 minutes to cross the whole width of Earth's orbit. His number was rough and a little too slow, but the point was never the number. The point was that there was a number at all. He was the first human being to prove that light takes time to arrive, and that single idea rewrites what seeing even means. Because a finite speed, however fast, means a delay, always. The sunlight on your skin right now left the sun 8 minutes and 20 seconds ago. You are not seeing the sun. You are seeing where it was and how it looked before you sat down. If the sun went out this instant, you would feel nothing, see nothing, know nothing for 8 full minutes. You'd carry on, warm and unaware, inside the light of a star that was already gone. And the sun is the closest star there is. Push past it and the delays stop being minutes. They become years. The next nearest star, Proxima Centauri, is 4.25 light years away. The light from it arriving tonight left more than 4 years ago. But that raises a problem. How could anyone possibly know that? You can't run a tape measure to a star. The answer came from a woman named Henrietta Leavitt at the Harvard College Observatory in 1912. She was cataloging thousands of stars by hand. Women then were hired to do the counting, the men wouldn't. When she noticed a pattern in a certain kind of pulsing star, the slower it pulsed, the brighter it truly was, which meant its real brightness could be read straight from its rhythm. Compare that true brightness to how faint it looked from Earth, and you could calculate exactly how far away it sat. Leavitt had built the first ruler long enough to measure the universe. For the first time, we could put a number on the distance to a star, and therefore on the age of its light. And that ruler delivered something no one was ready for. If a star is thousands of light years away, then its light is thousands of years old enough that the star could have died in the meantime, and nothing would tell us. The light keeps coming anyway. Some of the stars you will look at tonight are not there anymore. They burned out centuries ago. Their light is still crossing the gap, still arriving, still pretending to be a star. You are looking at ghosts, and the deeper you look, the older and emptier the sky turns out to be. Leave our galaxy behind, and the past becomes almost unbearable. On a dark, moonless night, far from any city, you can find a faint smudge of light in the constellation Andromeda. It isn't a star, it's an entire galaxy, 1 trillion suns. And it is the single most distant thing a human eye can see with no help at all. The light landing on your retina from it tonight left 2.5 million years ago. It began its journey before your species existed. When those photons set out, there were no humans to catch them. Only early, upright creatures on an African plain, chipping the first stone tools. That light crossed 2.5 million years of empty space, outlasted the entire rise of humanity, and ended its trip inside your eye tonight. You are the first thing it has touched in all that time. And your eye is a weak instrument. Give us a good enough telescope, and the past opens almost all the way to the beginning. In 2022, a new machine a million miles from Earth turned toward one dark, empty-looking patch of sky and simply stared. The James Webb Space Telescope was built to catch light so old, so stretched and faint, that every instrument before it had been blind to it. In that black patch, it found galaxies. One of them, cataloged as Jade's GSZ-13, sent its light toward us 13.4 billion years ago. You are seeing it as it was barely 300 million years after time itself began. Not a star that has died. A galaxy from before the Earth, before the sun, before nearly everything, glowing in an infant universe that had only just switched on. So how far back can this go? Is there a bottom to it? There is. In 1965, two engineers at Bell Laboratories in New Jersey, Arno Penzias and Robert Wilson, kept picking up a faint hiss in their antenna they could not get rid of. It came from every direction of the sky, day and night, all year long. They checked everything. They even scrubbed the droppings of nesting pigeons out of the horn. The hiss stayed. It wasn't a fault. It was the oldest light in existence. The leftover glow of the universe itself, set free 13.8 billion years ago, the moment the cosmos first turned clear enough for light to travel. It is the furthest back anything can ever see, not because our instruments are too weak, but because before that light, the universe was a fog no light could cross. That hiss is a wall at the edge of time. Look as hard as you like. Build any telescope you can dream of. You will never see a single moment older than that. Sit with how strange that is. The beginning of everything didn't vanish into the past. It's still here, still falling on the earth, on the roof over your head, on you, every second of your life. The oldest event there ever was is quietly raining down on the back of your neck, and you have never once felt it. And here is where it turns. All of this sounds like a loss, as if you can never touch anything real, only old light and ghosts and walls. But turn it around. The delay is the only reason you can see far at all. If light were instant, the sky would show you a single flat now. No depth, no history, no distance. Because light is slow, the sky became the one place in your life where the past stays visible. The night sky is not a picture of the universe. It's the universe's memory, stacked in layers of time, and handed free to anyone who looks up. And it isn't only the stars. The face across the table from you is a few billionths of a second old by the time you see it. You have never once seen another person as they are, only as they just were. So the next time you step outside and lift your head, remember what you're actually seeing, not the sky as it is, a sky that has already happened, some of it gone, some of it long dead, some of it from the dawn of time, all of it still traveling, all of it ending its journey tonight in you. You will never see the present, but you get to stand beneath the entire past and call it the sky.